interactive session today, and there are several questions which we are getting. Though I have tried to answer several questions through my messages, and wildfire, I have also shared our paper which we have written some time back. Whenever you get time, please go through it. So, Satyendra, yes, I think you will get answer. It is a big mystery for everybody. So, I think we can't discuss much about it, but please go through the paper and try to create another paper out of it and with what is happening right now. Rishi, can you explain exactly process involved in the waste to energy plant? So, this I will like to do today. I think I have sent you some information on WTE also. Sakshi, wouldn't phytoremediation be very long process? Yes, but or are there some specific plant that cleans the toxins faster? I mean, I am not a biotechnologist, I am a plant pathologist. I will not be able to answer this question, but one of my consulting projects which I did very close to JNPT, Jawaharlal Nehru Port Trust, because of the oil spillage, there we used marigold flowers. They are supposed to be the best agents or the plants to uptake the toxins from the soil. This question you should pose to some agriculturist, or you should read if you are so much interested. So, phytoremediation is a very long process, yes, but then money is also a very important thing, because there are many sites where you cannot take any invasive measure. Invasive means you can't go and extract or excavate the soil. So, what you will be doing? Look at like Cuff Parade, Marine Drive, all these areas. So, this is where if time is not a big issue, what normally they do is they go for a trade off between time and effectiveness of the methodology. So, there are several methods you should read. I think I have sent some information also on this. Here I would like to mention that there is one instrument which is known as FTIR, Fourier Transform Infrared Spectroscopy, FTIR. FTIR is used for checking. Suppose if you start your consulting firm tomorrow, so what you have to do is initial condition and subsequent treatment if you are giving, and then keep on taking the samples from the ground and show to people that whatever you have proposed is effective, all right, and then charge accordingly. So, FTIR is very useful for this, ICP MS is very useful for this, inductively coupled plasma mass spectroscopy, MS, mass spectroscopy. What is the concentration of the mass which is present in this system? If you have time, accompany one of our PhD scholars here and go along with them to SAFE and see what is happening there, because fortunately in IIT Bombay under one roof all these facilities are available. Fine, there is no other IIT which will give you these facilities. Your second question is, so I am passing this question for the time being, all right, then you have to talk to agriculturist, florist and so on. There is an interesting subject in geo-environmental engineering which is known as bio-geo-environment interface, all right, bio-geo-environment interface. So, how these three things work together. Another one is root soil bacteria interface. So, there are experts who have done geotechnical engineering and after that they have become plant experts, vegetation expert. Gas hydrates were mentioned in class and reserve, wouldn't this explosive? No, I think this is a misconception. So, we will discuss about gas hydrates after a few days. Let us discuss today municipal solid waste and industrial byproducts. Prakhar is not here, but it is possible to use technology like ultrasonic X-ray imaging. Yes, so I am going to discuss this today. Who are experts in designing the landfills? Very simple thing, but for this you should have strong concepts of geotechnical engineering. You guys are from second year? Both of you? So, you are doing any course on geotechnical engineering right now? Soil mechanics is geotechnical engineering. Fine. So, the strength of the soil mass, because these structures are made up of soil and they are sitting on the soil. If you look at the foundation or the base, this is the soil mass, and this structure which is behaving like a landfill is also made up of soils. So, what I have tried to show here is what a landfill is. So, it is a sort of a bucket which is sitting inside the ground. So, there are some landfills which are deep inside the ground and there are some landfills which are above the ground, depends upon what type of waste you are handling. So, what you have to do is you have to provide a liner so that the waste, when it gets decomposed, the leachate should not come out and they should not contaminate the ground. Fine. And then you have to make sure that whatever gases are getting generated because of decomposition of the organic waste, that gets sucked out from the vents which you are providing. So, this is a typical cross section of the landfill, fine, where you have a bottom system which is foolproof, nothing will percolate out of it. This is the waste which is lying over here, then there is a top cover. And then there are different types of wells which are provided to take out the liquids. Liquids are getting formed because of decomposition of the waste and the gas is also getting formed, that is also taken out. So, these are known as gas vents and leachate collection galleries. Fine. This is how the gas vent looks like. In your pressure cooker you have a gas vent, no? The whistle is a gas vent. The same thing is happening here. If lot of decomposition occurs inside the landfill, lot of gases will get formed and if you do not give them escape route, what will happen? The whole landfill might get exploded like a balloon. And you must be seeing that cities like Bombay, a big chunk of population is living either in the vicinity of these landfills or on the landfills itself. What is BLF, bioreactor landfill? I just was discussing about it. So, what happens is, it is just like your stomach, human body. Whatever you eat goes in the stomach. If you eat too much, it gets upset. All right, excreta is formed in the form of gases, solids, semi-solids and liquids, correct? The same thing is happening over here. Now, the trick is, if I collect liquids which are going out and recirculate it in the system, and if I digest the waste by using this leachate, I can accelerate the process of decomposition. This is what is known as bioreactor landfill. Two of my PhD scholars worked in this topic and one of them is a now faculty at Cardiff University and another one is a consultant. Yes. What is the? Leachate is something which so this is the landfill which is below the ground and then covered like this with the MSW. Now, if I do not provide this cover, what will happen? All the rains which are falling, they will interact with the matrix of the waste and then what will happen? All these liquids will take out the toxic elements out of it. This is what is known as a leachate. All right. So, leachate is basically a liquid form or a semi-liquid form mixed with gases, which is an offshoot of interaction of water with the waste matrix. This can also be because of the fluctuation in the water table. If this is the water table and if you do not protect your waste, if you do not make it waterproof, the chances are water will go inside, waste will become wet. After a certain time, all the heavy metals, the leachates will come out. So, these leachates could be waste components, heavy metals mostly, gases, combination of the two and so on. And nowadays, there is some word which is used as emerging contaminants. So, PFAS is one of them. Our Pandey is expert in this and Mrinal, they are working in this area. MPs and NPs, microplastics and nanoplastics. This is the state right now. Plus, you can have bacteria also coming out of this, microbes. virus. During COVID time, the big problem was how to handle the virus migration and so on. Now, if this liquid I collect and if I recirculate it in the landfill itself, if I have a system by which all this percolating material will be collected in a drainage gallery, from here I will lift and push it back, then this becomes a bioreactor landfill. That means you are utilizing the aggressive nature of the leachate to decompose a organic substance. So, MSW is nothing but organic matter. Organic matter and VOCs, volatile organic carbons, hydrocarbons, volatile organic contaminants. Fine, good enough. Sometimes what people are doing is, the way you want to enhance your digestive capacity, what do? You add some enzymes, digestive, correct? So, what I can do is, in these leachates I can add some augmenting agents. This is what is known as leachate augmenting systems. Either I can heat it up, that is one way, I can add some chemicals another way, I can add some microbes another way. This system I had created in front of hostel 10 years back, a small unit. Now they have demolished it because our experiment got over. So, we wanted to show that the campus waste can be decomposed and enough methane can be created out of it. This was the PhD done by my PhD scholar Dr. Patil, very active person. So, because he has learned all these tricks, correct? Society, ecology, finance, technical issue, nobody can beat him. Fine. Your question, no, this guy has asked, Prakhar, he is not here. So, how to detect all this? There are several ways. So, what I have shown here is, if I drill a hole, in the first, second lecture I was talking about sampling is also very difficult, because the chances are the methane may come out and it may catch fire and it is very dangerous, because you are standing on the top of a landfill, nobody will dare to do this except for some of my students. Agnes Ento was the one who did all this. She is a consultant now. What you are seeing here is a lot of gas mixed with the leachates and it bubbles. So, it shows that landfill is alive, active, and hence you cannot do biomining. Now, check most of the cases which are being fought in Supreme Court and NGT on biomining, and what is the main issue and why I am an advocate there. Got it? Because that is the major issue. Somebody says clean it up. If I clean it up, what are the hazards associated with it? Have you heard about it? You want to make money, but at what cost? Second thing is where I am going to keep it. So, this is Mrinal's topic, he is working on this. If I remove the landfill, where this material will go? How to utilize it? So, one is working on industrial byproducts. If I remove this hillock which I have shown you, where I am going to dispose this? Hope you have understood. This is a typical waste to energy plant, which is at waste to energy WTE. If you have time, we can go there. This is how it looks like. This is the process which you are asking about. What are the processes which are included? So, RDF is residue derived fuel, all the plastics and the undecomposed material. This is basically kept inside a what do you call it, a sump pit. So, this is the class which I take is for of second year students, third year students, fourth year undergraduates. Just give me 1 minute, I was talking about waste to energy, and just I will complete in not more than a minute, and then we will interact with you. So, this is basically contained in a pit, and then you have to fire and get the heat out of it and connect it with the power grid. Fine. So, I will stop here. Let us now talk to Andrew. Good. Thank you very much for being with us, and My students can see you and they can hear you. Very good. So, now we are all set. You can see yourself on the screen and my students are sitting here, and the whole thing, the intention of calling you here was to maybe share your views and thoughts on why somebody should become an environmental geotechnologist.
Okay.
And what are the challenges one faces, and because these are all young guys, we have to motivate them so that some of them would join the league. So, now the floor is yours. We will ask you a few questions, and I know fully that your background is from environmental engineering, the type of projects you have dealt with in the past, and what is the challenge in those projects which you have faced, and how you shaped up your career. And of course, this batch of students would also be very eager to join you or your university as a short-term internship or for higher studies. That also we can do.
Okay.
Yes, please.
Great. Okay. Well, thanks for the invitation, and it was a very great opportunity to have a brief chat. I suppose. Okay, my background: I'm a geochemist, so I've been associated with a whole range of projects from my PhD through to current batch, really associated with resource management, waste, environmental impacts, and implications for human health of emissions of potentially toxic and harmful substances in the environment. And that's been through case studies in nuclear waste disposal, the impacts of radionuclides on the environment, through to waste from steel manufacturing, impacting on groundwater, the pollution of agricultural urban soils with a range of substances, mainly emitted from industry, through to aquatic systems that also have received significant human disruption and interference, which comes up to date with work in collaboration with IIT Bombay on antimicrobial resistance in estuaries. So the story is quite extensive. I've worked in China as a key lab researcher looking at mining wastes and impacts on the environment, and in Paris as a visiting academic in the Geological Institute there, as well as colleagues in other parts of Asia and Europe. So the challenge is really one of opportunity, I guess, finding those opportunities that excite you, but also those opportunities that open up to you, because everything you want to do is not always feasible. And so you find the door opens where you don't expect it, and you must take advantage of those opportunities. So you can plan your career, but you can't guarantee the path. So I guess the key bit of learning or recognition now, as I am a lot older than when I started, is from that experience of engaging with the community and not being scared to talk to different disciplines. And that I guess is one of the big challenges if you're an engineer or a material scientist, and you have to have a conversation with an ecologist or a human health specialist, or how do you share a common language? Because the big challenges we have and the opportunities in the future cannot be solved by one engineer or one chemist. So this is the challenge, but it's also very exciting. If you are able to enter into these environments to carve your future career. So when you start in your educational experience, then you look for opportunities that give you solid grounding, but also opportunities to travel and meet. So I can see you now. And
yeah, you can see the participants.
And hello from Scotland. So yeah, that's just briefly some reflections, some thoughts. I'm not sure if that's given you something to think about or to question.
Yeah, so the question is that because most of them have not started their career yet, they are undergraduates, and I am sure the basic idea of taking up these challenging tasks related to mining. Incidentally, some half an hour back I was discussing about the mining issues.
Okay.
Particularly the bauxite residues, waste to energy outcome, where are you going to dispose it and how. So, how this undergraduates should be shaping up their thought process so that they can become champion in the subject tomorrow. Of course, they can always ask these questions, you are free to ask this question please, but from their side I am posing this question to you.
Yeah, well, I think it's again goes back to finding learning opportunities where you get exposed to other thoughts and other disciplines. So, for example, we have a master's program here at UWS that's been running for 30 years under different names, but essentially waste and resource management, environmental management, and the class is typically from 10 different countries, and the background of the students is also equally diverse from all types of science and engineering, and so we share those experience with the group and bring their experience to the class. So we have problems in recycling that we put in the context of, where the class comes from, and give the class the opportunity to contribute. And that generally leads to quite a good exchange, and over the program, a lot of good friendships building to share those experiences.
So, one question which comes to my mind is that India is developing and Western world has stopped mining. So, the problem which you have, this is a contrast. We are developing, we have to do more and more mining, and you guys have stopped doing mining, particularly coal and other precious minerals.
Yeah.
And then people are talking about the critical minerals, which we will come to later on. The first question is that there are several issues associated with mining. We have to dispose the tailings, we have to dispose the mining water, how to clean it, how to make it potable, and so on. Yeah. So, what was the policies and the decisions which EU took long back?
I think a lot of decisions were not decisions; they were circumstance because of the global change in economies, from moving mining activities away to regions where they're more cost effective, cheaper. The footprint of mining in a very densely populated country, or relatively densely populated country, means it creates big challenges. But I guess it was more of economics. If you think about coal, that the UK coal became too expensive for the UK to afford, whereas cheaper imports from other parts of the world.
No, Germany also banned coal mining, correct?
Yeah.
Belgium also, for that matter.
Yeah. So yeah, absolutely, and I guess the underlying.
So if you extend this question further, how are you going to meet your energy demand, which is going to be very critical in today's world, particularly keeping in view in what's happening in Central and Eastern Europe?
Absolutely. Well, the promotion of renewables is very high, but the capacity is quite low, and we have days when the sun isn't sunny enough and days when the wind isn't windy enough to increase the capacity. We don't have the battery storage to complete that cycle of supply. We have oil licenses for the North Sea that have been closed and then suddenly reopened, particularly in response to Ukraine, Russia conflict. We have known resources for shale gas, which we have a moratorium on. In Scotland, a complete ban, but not so in England. So we have slightly different laws in Scotland from England, particularly in environmental perspectives, and it makes exploiting the resources we have quite different in different locations.
So any questions, please feel free. You should participate. Yep, any questions? Yeah, please go ahead. I'm just invoking them to ask questions. Yeah.
Okay, so and we are thinking about critical materials as well, and we are looking at the old mining residues for some potential resources, and in particular in Cornwall, in the southwest of England, lithium is being assessed quite actively, as an example. So we've got very good data from the Geological Survey of the UK of historical sites, as well as one or two potential new ore deposits that can be exploited.
So when you say critical minerals and this lanthanide series, what is the major issue associated with lanthanums and lanthanides? Like why can't you mine it? What is the major issue? Environmental issue, and what is the issue? Is it a political issue or it's a technical issue?
Political issue in that the resources are held, or the majority of the available resources are held in locations where the political climate is not necessarily open for global collaboration. So I think a lot of the and economies that want to exploit it themselves, whereas there are other locations where there are resources, but the country is not stable enough and capable enough in terms of resources to exploit, and so you have international.
No, so what is the reason? Why they are not capable enough? Where do they lack?
In terms of the technology and the organization, so we have large multinational companies that are often supported by strong governments that make it easy to almost invade locations. So cobalt in Africa is particularly a big challenge, and again, I guess the power of financially strong institutions moving to exploit with the support of perhaps a less strong government.
No, so you are an environmentalist, and suppose if I do mining of lanthanides, in what way the treatment of the mined out material would be different than the metals which we were earlier, mining out, coal which we were mining out? In what way it is different? What is the basic difference?
So some of the basic differences in the mineralization and the nature of the deposits, chemically, associations that require different treatment processes for the ore itself, and we also have perhaps less experience in terms of large-scale industry for that exploitation, particularly where those deposits are not so rich. that we have limited capacity to deal with these tailing materials, and the rare earth elements are quite difficult to process because of their solubility and geochemical reactivity, and equally we don't know much about their impact because they have not really been encountered in the same way as, for example, arsenic and copper and lead, which are often either the targets or the associated with the ore deposits.
Okay, let's take few questions from the audience. You want to sit here? Please come. Yeah, you can come over here. Pull this chair.
Hello, Prof.
Hi, good to see you.
Good to see you too. Like, I had a question. Like, in your country, like you mentioned, you stopped mining of the coals, right? So, what about the previous mining? Like, there must be the mines present, right? So, you closed the mines, or what are doing with the mines now?
So he has to be sent to Germany to see what has happened with the closure of the mines.
Yeah.
You know this?
Yeah.
You should go and visit. You should see what's happening in the Western world.
So, I'm not aware of that. So
No, you have to see things. Okay, so and in Scotland also, most of the mines have been shut down.
Yeah, we have
there is a mine closure program.
So all the mines are closed now?
Yes, they have been shut down.
Okay, so they are not utilizing for other purposes like we
No, just send her out of the class.
Not.
You are not interested, please go.
And the legacy we have is the empty mine, which is full of water, and that water and the water that's produced is often acidic, and so we have acid mine drainage, which is a liability. We still have a coal authority, and it's more their responsibility now to protect the environment from the past.
See, because of acid mine drainage, a lot of coal mines in India also have been closed, shut down, particularly in northeast, because this coal, which produces a lot of H2S, or H2S later on reacts with the oxygen, becomes sulfuric acid with presence in water and so on. Then a lot of leaches get generated in the whole Arunachal Pradesh, northeast. These areas were getting heavily contaminated. The whole water was becoming acidic, sulfuric acid. The color was red. Type it on internet, you can see why they have shut down all these mines in the NCL, Northern Coalfields.
And some of the opportunities, though, that we do have are in terms of energy sources from low temperature water, subsurface water, in terms of heat source. And there is an initiative in the UK through the British Geological Survey. They have established a number of subsurface observatories where they're looking at exploiting potential low energy resources in former mining sites.
I think a good example is CBM. What you are doing in hydrates is coal bed methane. So they are now taking out all the methane which is embedded in the coal beds, and then they are trying to use this methane. This is known as CBM technology. You check it out on net, CBM. And sometimes they are also doing CCUS in coal seams.
So, like, I have a question here. Yeah. If they have closed the mines, how these activities are being done now? So that was my question.
Then the way you do CCUS. You have to inject, yes, you have to inject. Now you have to open it.
Yeah, borehole has to be created then.
Borehole has to be created and you have to inject carbon dioxide, and this becomes a very good receptor. Why? Because of the porosity, because of the adsorption capacity of the gas with the coal.
Okay, and so one more question, like you were mentioning about the alternate energy resources in UK, right? Because the mining has been closed now. So what is the status of the using of the geothermal energy there? Like, is it progressing, or it's like what?
There's very limited geothermal. Some areas in the southwest of England are
Scotland is the best place for you.
But the other renewable energy sources are, in terms of wind and onshore and offshore, and a little bit of solar. It's mainly, and some hydroelectric in the Scottish Hills, are expanding slowly, but of course it's always economically limited in terms of, we should have invested in this 20 years ago, but
no, you have nuclear also. You have nuclear also,
and we have
a lot of oil and gas.
Yeah, we have old nuclear.
Yes,
but also we have the encouragement of new nuclear, which are smaller reactors, and there are some signs of collaborative agreements between, for example, I think Amazon and Meta have signed deals with nuclear power companies in the UK and in the US to collaborate with small nuclear energy sources to ensure that data centers are supported into the future for the AI explosion, and that is something that, again, I think in Scotland we are encouraging investment in this renewable energy technology to support.
You are very close to Aberdeen also.
Yeah, it's all relative.
So Aberdeen is the university, where most of the research in CCUS, gas hydrates, oil and gas is being done. Aberdeen is the mecca of oil and gas research. Yes, yeah, you want to come? Yeah, come, no problem. We are going to close this session very soon. Yes, another student.
Good evening, sir.
Hello.
Good afternoon there.
Good afternoon there. So if nuclear is going to be the future, so like then the reactors will be everywhere, then how big of a problem is going to be the nuclear waste? Because
good question.
Yeah. Well,
this industry in India is going to be privatized. We are going to have, every locality might be having a nuclear reactor. We are going decentralization and PPP, private public partnership in nuclear energy. Otherwise, you cannot meet the demand of India. It's in gigatons, gigawatts.
Because I was reading somewhere, like right now renewable is very, very high in the topic. So like let's say we EVs. So now if every petrol car is supposed to be replaced by EVs in the next 20 years, we have to do so much mining that will totally dig up the earth. So then
not only mining, how will you charge these EVs?
Yes, so it's by electricity, and then we come back to the...
So that's first question. Second question is what he was talking about, critical minerals. From where you will bring critical minerals for energy storage, batteries.
Yes.
Number 3, after end of the life, where are you going to dump them? Then as a environmentalist, he is saying that nobody knows what will be the impact of these minerals in the long run on the environment.
Yeah.
So this is a big crisis.
For example, some of the emerging pollution from rare earth elements is only now being understood. We haven't had exposure of aquatic systems to some of the discharges that we have, for example, with lead and arsenic and copper. It's really quite well understood, but some of the new materials and the elements that we are concentrating now in new technologies, then the wastes will generate higher concentrations of potential effluents. Even if we recycle, there'll still be waste. And so we still don't understand the potential impact of these concentrated elements on living systems so well. So it is a big challenge. But I guess the nuclear option will be another contributor, not an exclusive situation. So we're going to have to have a mix of energy, but also energy efficiency, I guess, which will help reduce demand on particular particular sources. And it's that balance, I guess, that we want to promote. So businesses are encouraged to think in terms of net zero. Net zero is more a marketing tool than reality, because we will never be net zero, but we can be better.
So, Nuclear Proliferation Treaty, NPT, and then that was the time when India was deciding whether it should go nuclear or whether it will go thermal. Thermal has fizzled back, correct? Now we do not have any option. Nuclear, people are resisting. So, one of the biggest plant of nuclear power which was going to come in Ratnagiri, you know the name? What is the name of the place? Tarapur is in Maharashtra, and and Gujarat border. What is this place? Tejapur. So, villagers actually protested there. So, see, this is becoming a subject on its own.
But isn't that mostly due to like myths and like?
No,
nuclear isn't that
no, don't say myths. You have to respect sociology, you have to respect politics, you have to respect economists, you have to respect demographers, you have to respect environmentalists, then you have to decide something, you have to respect everything. This is becoming a big nexus. So, anything,
Absolutely.
yeah, so I have another person who would like to ask you a question. Yes, please.
Good afternoon, Professor. As you mentioned that currently the mines, all the things have been stopped. So, what is the current plan to utilize that tailed material? And is there a way we can make it more resourceful? As you are into resource management.
So, let me introduce him. He is working on man-made soils by utilizing the industrial byproducts. Very ambitious project.
Okay.
And he is trying to utilize all the trash which is coming out of the bauxite industries and the slag which is coming out of the steel industry and all sorts of materials, phosphogypsum, and then he is trying to create artificial soils. Yes, please go ahead.
Techno soil, yeah.
You should introduce yourself like this. This is what you are doing. Okay.
So,
This is one question.
Now, what is the question?
The question is there a way that the tailed material can be used as a resource? Is the government planning on it, or are you working on it?
no, I think with many mine closures, it is more a localized decision. So the owner of the site has to ensure that any potential hazard is mitigated against. So quite often the materials are isolated and capped, and sometimes they build leisure facilities around them in parks and sort of areas for gentle recreation. So the general strategy is more or less to make safe and leave. Whether or not there are opportunities to revisit these waste materials and evaluate them for whatever potential resource use they have, I'm not clear. I think it's mainly hazard mitigation that is the strategy. When we're looking at development of new buildings and things in urbanized environments, then it's often the reuse of construction and demolition waste as a foundation for the buildings. But making a soil that is then productive as a soil, as a substrate, is a very, very, very interesting challenge. In can you perhaps use for biomass production or something as opposed to food crop, and those decision options are really quite a big challenge. So your TechnoSol, what are you designing it for?
We are designing it to use it for infrastructure development.
As a backfill material.
Yeah.
by neutralizing it with the different types of gases. That is CCUS part. He's a very ambitious guy. He's doing a lot of things.
Yeah, yeah.
Okay, thank you. Yes, please come. Introduce yourself and what is the question?
Good afternoon, Professor.
Hi there.
Myself, Yogi Prakash. Actually, my question is today also Professor DNS was discussing about the red mud disposal. We have a huge disposal lands where the red mud is present, and I'm sure it's there worldwide. So, what's the government is planning to use it in the industry, or what is the usability of those disposal lands, like the usability of the red muds? What exactly we are making out of it, or can be done in future?
Yeah, I'm not so clear about how much of a burden it is in the UK. Again, because we tend to import more of our raw materials pre-processed. So I've seen some processing facilities in Portugal, for example, where they are
Brazil.
looking at potential for...
The maximum is in Brazil. Brazil is number 1 in alumina extraction. So, most of the industries where the alumina is being extracted, Brazil, bauxite deposit, Brazil is number 1. We stand 4th or 5th. Now, this is a very interesting point which he has raised, Andrew. The type of problems which you are facing, we are not facing. And our problems are really out of the world, out of the blue, you may say. So, land creation, I am sure, is not your agenda, because your population is limited, your land is infinite. Here, population is infinite, land is limited, correct? So, this is the contextual problem. So, maybe his perception would be different. Now, what you have to do is, nobody will answer this question to you. What you should be doing with your waste, utilize it, valorize it.
One thing, I was working under Professor Solomon here. So, actually, we are making a geopolymer out
very
of
good.
the red mud.
Correct, correct. That is the answer. But take it to an industrial level.
That was
from lab to the industry, scale it up. That would solve problems and sell it in the market. Geopolymerization of bauxite residues, activated with some activator, slags, hydroxides, sodium sulfate, sodium silicate, and that's it. Good. I mean, you should realize that when two people talk, his problem and my problem may not match, because they are in a different world. Their issues are totally different. They are least bothered about what's happening. It's our problem. We are not breathing fresh air. It's not their problem. They laugh at us. Don't worry. This is how you learn. Correct. Come. Good. Anything else?
No, thank you.
Come. Ojas, what's your question? I think their internet is weak, or our internet is weak. Ours? Not ours is full signal. Yeah, you are back. Good, thank you. Yes, please.
Hello, Professor. I'm Mojas. Hi.
Hi.
Yeah, so I often this notion comes up, especially as an environmentalist, that you have difficulty as a researcher trying to get your solutions or get your ideas into industry, because for industry it often comes at a cost rather than an incentive. So could you perhaps share a few personal experience of your projects being introduced in industry or being used in industry, and perhaps some solution which you think governments or controlling bodies could come up with that allows researchers to ease their solutions into industry, have a more smooth transition process?
Yeah, that's a really good question, and it's one that I have a really good answer for. And that is an initiative that the UK government, it's going to celebrate this year. It's the 50th anniversary of this program, and it's called a Knowledge Transfer Partnership. And rather than a researcher going to industry, industry comes to the academic base with a problem, or they collaborate with an issue. And the government offers a 50% grant if the industry covers the rest. And this covers the cost of an innovator, an R&D specialist working in the industry supported by the academic. And the project is evaluated not on papers, but on the performance of the business. So the plan is for a 2-year project to develop something that will take the business from its current state to a higher performance. So it might be a new product, it might be an improvement in the process, it might be even a marketing campaign or something that takes, based on scientific underpinning, an issue forward. And so we've had a number of these, particularly in the waste and resource management sector. We had one with a big food company in the north of Scotland. They had a wastewater treatment plant sitting on the banks of one of the most important rivers for whiskey production. And the regulator said, no, you cannot discharge into this river because everyone else needs the water. And so they had a lagoon, emergency lagoon, that was continually flooded by the process wastes because they had a wastewater treatment system that had to deal with, on 1 month, the manufacture of a dairy product, a meat product, and then the big challenge was in the autumn when the pickled vegetables were produced. And so the wastewater, like anyone who eats a bad diet, the wastewater treatment system couldn't cope, and so they were having to dose and fix things. So by mapping and balancing the system, we were able to support their operators to move forward. Another one was the whiskey industry has very, very stringent copper discharge limits. And we worked with a company who were able to offer a cleanup solution for the industry, but they had a problem where they cleaned it up, but didn't know what to do with the material that they inherited. And so we were able to work with them to clean up the absorbent and generate high quality copper salt from a very, very low level that the company could sell back to the pigment industry. So there's a circular process there. And all of those steps involve scientific evaluation and supported by scientific understanding. And we've published a number of papers on that showed or provided the business, the regulator, with the confidence that the decisions were robust. So it wasn't our research idea necessarily, but we used our research capability to produce robust results. And the program is across the UK, and it has 50 years worth of data, and it shows that for every £1 spent by the government, there is a £4 to £5 impact on the business. So those, and it's not focused on 4-star publications, it's focused on business performance and sustainable business performance.
Yeah. I mean, thank you. That's exactly what I was looking for. I mean, you need to find a way to have this sustainable, but you need to keep the business going, obviously. You want to save the environment at the same time keeping this going. You can't have one without having the other. So yeah,
sustainability has all those 17 traits, SDGs. Yeah. So you can't define them.
And sometimes the businesses have been spin-out businesses from the university as well. So there's a double hit. You've got the idea from the university, and then the university supports the business to grow. You know, and it's as a geochemist, it's often not so close to my direct experience, but the processes are interesting. The one we have now is a plastic sports turf recycling business that has, you know, problems separating the plastic. No, it can recover the plastic, but the fill in the sports surface is a mixture of sand and rubber. And so we go back to some basic hydrocyclone processing to try to recover the sand and separate the rubber and send it back into the system. And we have an engineering student who's a graduate who's now working in this company, but he's trying to work out how to weigh the turf on a truck when it comes back, so that they can do a mass balance and improve the efficiency. You know, so the skills from university are just as essential for process manufacturing industry, and can be quite exciting applied research in these areas.
So Andrew will take last question, and I know we have already encroached upon your enough time. So the last question comes from Dr. Surendra. He has been working on geopolymerization of mine tailings, iron mine tailings.
Hello, Professor. Good afternoon.
Hi.
I am
Good to
Dr.
see you.
Surendra Singh. Thank you for your insight regarding various issues related to environmental. As I see from the background itself, I think it's one of tailing storage facilities, if I presume.
No. This is a beach in the north of Scotland. If you look carefully, it's nice seaside in the very, very far north of Scotland, next to a distillery where we did some work on ceramic waste.
Okay. So, because by the look of that background, it seemed like a tailing ponds facilities, because there also slurries are stored.
Yeah.
It's misleading.
It's the beautiful Scottish water.
So my question was related to that only, because you, Professor, also mentioned that mining has been mostly stopped in the European countries, but in other part of world, like in Brazil, China, India as well,
Indonesia.
lot of yes, sir. Indonesia, lot of mining operations are still going on.
Australia.
Yeah.
And also Australia, that is one of the largest countries which is producing a lot of mining waste. So in general, these are being stored in these tailing storage facilities. So are any there other way of storing them or handling them so that the environmental issues created by these facilities can be minimized? I know people are doing for the dry stacking also, but are these solutions permanent in terms of environmental issues, or what is the way in which this can be minimized, these environmental issues?
Is there some literature on this, Andrew?
On mine tailings, generally the literature on mine tailings, as I'm sure you're aware, is when it goes wrong and the tailings fail and pollute rivers and things like that. So a lot of it is about stability, geotechnical stability, but also changes in water, which is the threat always, sort of landslides and collapse of the structures, and is very difficult to exclude water from materials that are stacked on the land surface. We do have a project where I'm part of a supervisory team for a student who's looking at deep sea tailings deposits in Indonesia, which is against the moratorium that most of the world had signed because of the very simple fact that there isn't a safe enough place on land to store these materials in a geologically disrupted environment. So we have really very need to carefully look at the locations and the conditions that are likely to prevail for decades. So that brings into shot all of the extreme events that we will see increase over time, and this is a big threat to any disposal. Well, it's not disposal; it's storage, isn't it? It's not until you can identify a safe use for this material, either put it back, which again is not very cost effective, or stabilize it so it can be used as a surface for something. And quite often that would be perhaps from a sort of a stability perspective, something that you can build on rather than use for sort of primary, say, agriculture or anything like that. So yeah, I'm not aware completely of the current practice, but you know, we have I guess a lot to think about in terms of water and slope stability under different climatic and geotechnical.
These are pure geotechnical problems. Okay, I think we'll have to wind it up here. Thank you very much for your time and for your enlightening talk. And I will approach you to write a bit on whatever we have discussed in the form of an editorial for the next issue of the journal. And maybe you can write for 2 to 3 pages, and because the type of projects which you have been into are really marvelous. So, not now, maybe by the end of the year, I will contact you maybe by October, November, and then I have done the recording of this talk interaction, and I'll post it to you. Thank you very much.
Thank you, and it's good to see you and hear you, and have a good rest of your lecture.
Have a nice day ahead. Thanks. Okay. Bye-bye.
Bye-bye.
Thanks. So, I think I'll continue with the rest of the lecture maybe next time. I hope you must have got a lot of feel of this. One suggestion is, when you are interacting with the international speakers, because their socio-political, climatic, environmental, financial conditions are very different than the one which we are facing, all right. So, whatever is a big problem for us is not an issue for them at all. Like when I talk to my friends in Moscow, they say they are enjoying in Black Sea. For them, war does not exist, correct? What is the longest range of the missile which you have? No, they don't care. We are worried, like if I take a flight to Moscow and if I have to go to Europe, how I will be going? So, for them it is not a problem, but yeah, it should not be a deterrent in you for asking any question. But what I am trying to tell you, like I don't know to whom I told that the issues which we are facing, we have to only solve. Hello, are you realizing? Nobody can give you an answer, and that is what exactly is happening in Indian industry. If you appoint a consultant, I mean, I know about the consultant, how much they charge and what do. They don't do anything, foreign consultants. So, all of us are heavily overloaded. We do teaching, we do research, we do this, and plus what do? We are heavily associated with industries. Why? Because somebody has to give an answer, and that answer should come from you guys. Why I am doing all this, I do not know, but I thought that some of you might get motivated. Realize the problem, because they know this, that we don't have solutions, because we have never taken these problems seriously. For a pretty long time, I think we were struggling for survival, is it not, since independence. Now, survival yardstick has been taken care of. Not many are dying hungry, I suppose, in the country. Not many, I am saying. But there was a time when many were dying hungry. So, there is a shift, and that shift has to be bridged with technology, and of course finance, and of course management, and of course international politics. Now, in a country where most of the manufacturing has been dumped by the advanced countries, now this again intrudes into your subject, what solutions we can provide? You have dumped all the manufacturing here, and then you are blaming us that we have not taken care of the environment. Which petroleum refinery you have in Europe? I have never seen. Out of my so many visits, I have never seen any petroleum refinery. What they have is all offshore. So these are the issues which we are trying to address. Fine? Okay, we will keep on discussing this. Thank you.